Hey, good evening, everybody. This is Rich Koucheravy. I'm the president of the Federal City chapter of the Vertical Flight Society, and welcome to our quarterly membership meeting for the first calendar quarter of 2021, and our first attempt at doing this by webinar. Since our last meeting was held in March of 2020, we did not have meetings over the past 6 months, and we've made the decision that in light of what's going on with the COVID virus, and our response to it, that we wanted to move forward with a membership meeting this quarter via webinar. I want to start off by thanking the Vertical Flight Society International for hosting our meeting on their platform. Specifically want to thank Mike Hirschberg, president of VFS International. I'd also like to thank Jim Sherman and Chris Thompson, who's running our webinar for us this evening. So gentlemen, thank you very much for all of your help, and we're looking forward to a really great meeting. Before I get started, I just want to make a couple comments about today's agenda. I want to remind everybody about our chapter officers, and most of which will be online this evening. So I'm your president. Garrett Jensen is our vice president. Lydia Jensen is our treasurer. Erica Oswiski is our secretary. J.R. Rigoli is our membership chair. Jim Cutting still runs our scholarships. And our new student chapter president from the University of Maryland School of Aerospace Engineering, Sehan Gul, who did the lion's share of the work of setting up this session today. And lastly, Dan Curry, who's our president emeritus, and continues to mentor the rest of the chapter officers. So thank you very much to our leadership of the chapter for their hard work in getting to where we are this year, that we can hold another meeting. Our agenda is going to be really three things. The first thing we're going to have is our traditional graduate student presentation. I'll introduce our graduate student presenter in just a minute. We're going to give that about 15 or 20 minutes, depending on how many questions you might have of our student presenter. Then we're going to kick off a panel of service representatives from the United States military. We plan to have service representatives from Army, Navy, Air Force, Marine Corps, and Coast Guard, and I will introduce those as we get the panel started. And after a Q&A session, we'll go ahead and go into a little bit of chapter business at the end and try to get the meeting closed by 8 p.m. this evening. A couple things as we move forward. I have not used GoToWebinar before. The control panel that you're looking at on the right side of your screen should be relatively intuitive for those of you who've been doing a lot of virtual meetings in the recent past. If you look toward the right, you'll have the opportunity. Most of you attendees, or all of you attendees, will have your mics muted, and we'll go ahead and unmute you. If you have a question, or what I'd like you to do is, if you can see on your panel where you can pose a question during that part of the session, go ahead and click on that, the question icon, and I'll call up and in order the questions come in, and I'll go ahead and read them out. Or I'm sorry, rather than unmuting you, we're going to have you just type your question into the question box, and I'll call out those questions one at a time for our presenters. Before we get going, looks like everybody's on board right now. All of our student presenters on board, as are the members of our military panel. So we're going to go ahead and get going. Let me introduce to you James Sutherland, the Clark Doctoral Fellow at the University of Maryland School of Aerospace Engineering. James is a fourth-year PhD student. His work on the design, modeling, and testing of advanced geometry rotors for model scale tilt rotors has earned him a #1 place in the National Student Symposium, hosted by the Society for the Advancement of Materials and Process Engineering. And he is competing in the Virtual Flight Society's lifting competition as a Southeast Region finalist. Last year, James was the team captain for the University of Maryland's graduate team, which won first place in the VFS student design competition, entitled Leonardo's Aerial Screw 500 Years Later. And that's what James is going to walk us through this evening, in a short presentation on the work that his team did in their winning entry last year. Upon graduation, James hopes to work in the industry, continuing the focus on rotor dynamics and structures. So at this point, I'm going to go ahead and mute myself and turn the meeting over to James, and he's going to walk us through a presentation. So welcome, James, and thanks for being with us.
Yes, and thank you, Rich, for the introduction. As you said, my name is James Sutherland, and I was the team lead for this year's UMD graduate team submission, which won first place in the 37th annual Vertical Flight Society Student Design Competition with our entry, Ellico, which was inspired by Leonardo's aerial screw 500 years later. And so the design for this was focused on studying one specific technology, which is the aerial screw. This was first sketched by Leonardo da Vinci back in 1489, and is considered to be the first heavier than air vertical takeoff and landing vehicle concept in history. And Leonardo hypothesized it could work in a similar way to like an Archimedes screw, which lifts water up a slope. However, since Leonardo's death over 500 years ago, there have been no detailed studies, no analysis on the aerial screw itself. So this challenge was aimed at finally evaluating the aerial screw's effectiveness at generating lift. And the final vehicle was required to rely on one or more aerial screws for lift and thrust. And the aerial screw is defined as a single-bladed rotor with a continuous surface and solidity equal to or greater than 1. Besides these constraints on the rotor, no other constraints were placed on the other systems to perform the mission. And while previous challenges have been focused on challenging missions to the top of Mount Everest, hovering for 24 hours, or flying on Mars, this year was solely focused on demonstrating the feasibility of an aerial screw for stable flight. So as such, the mission is designed to simply demonstrate stable hover and forward flight. So the prescribed mission was to carry a 60-kilogram human passenger or pilot to take off and hover at least 1 meter off the ground for 5 seconds, cruise at least 20 meters over the course of 1 minute, before hovering for another 5 seconds and landing safely. The total flight time is 70 seconds with a distance of 20 meters. But our design is capable of more than double each of these small requirements in payload, range, and endurance. The first step of this process was to determine the vehicle configuration. The initial concepts were divided into 2 groups. First, we had rotor configuration concepts, which were focused on ensuring the vehicle has a required anti-torque to hover through most conventional rotor configurations. A single main rotor with a tail rotor could be considered because the RFP only called for aerial screws to provide lift and thrust, while the tail rotor could be providing control. The second group of concepts was focused on vehicle control itself. Conventional swash plate controls can't be considered because the aerial screw rotor just doesn't mean itself to that geometry. Even conventional collective control is impossible because changing the pitch of the screw, how high or short it is, changes the surface area and would rip or tear at any surface. So instead, some creative alternatives were considered. Either placing the entire rotor on a gimbal, adding aerial screws on each side to be propulsors, adding cyclics to the tail rotor, which is placed off axis, and the most promising of which was placing a trailing edge flap on the bottom edge of this rotor. But since little is known about the actual operating physics behind this aerial screw, it's hard to evaluate how effective this would really be. And so based on our design drivers, we decided on a quad rotor configuration, which had the highest maneuverability and a simple anti-torque solution while being durable and robust. Here's an overview of the final design for Ellico. Just like the aerial screw itself, Ellico derives its name from the root word for the helicopter, helix, and screw in the Italian language. It has a maximum gross takeoff weight of 600 pounds, and each screw has a tapered radius out to a maximum of 4.8 feet. And due to the tall rotors, it stands over 11 feet tall with a footprint of 424 square feet. So it's overall a relatively large vehicle, but extremely light. In addition to the quad rotor configuration, Ellico relies on a modern aerial screw design for all lift, thrust, and control in flight. And each rotor is attached to a set of ultralight support arms consisting of a cellular truss to minimize the structural weight. Each of these components has a modular connection to allow for upgrades as the technology develops. And Ellico features an all-electric power plant system for efficient power supply to the rotors, and this allows the rapid RPM control required for flight. And lastly, Ellico can perform its mission completely autonomously with pre-programmed waypoints. But the heart of this design is the evolution of aerial screw. Our design philosophy was to make as few changes as possible to the original sketch to create an effective rotor while maintaining the elegance of the original concept. And the first step of this is reducing the screw to a single turn to reduce the load imbalance, and then increase the pitch for higher lift efficiency, followed by an aggressive 1:2 taper ratio, which is the real key to this design, and I'll touch on more in a few slides. And lastly, Leonardo's wood and linen materials were modernized to be aluminum, carbon fiber, and sailcloth to minimize weight while maintaining structural integrity. And the biggest challenge of this design was getting an understanding of where in the design space we could even land. This is a completely novel rotor geometry that has never been tested before. Going into this, we had no idea if the aerial screw could generate any thrust at all. There's no such thing as an airfoil, chord length, or angle of attack, so BMT, blade element momentum theory, or other preliminary analysis are not an option. And so instead, we had to parametrically evaluate a range of options to understand if a screw can provide any meaningful thrust. And this was an ideal use case for 3D printing, as allowed our team to rapidly prototype many designs with changes to the number of turns, the screw pitch, the taper ratio, hedral angle, and the placement of a winglet at the tip. And before the labs closed in March of this year, we were able to obtain 417 rotor test points to help further our design. And while this testing was able to show the efficiency of the screw design, we're still lacking an understanding of the physics behind it. And so for this, we took our 4 highest performing experimental rotors and ran high fidelity CFD analysis. And it was through this analysis that we found the lift generation is not through the rotor pushing air down, as Leonardo initially thought, but instead there's a vortex generated at the leading edge of the screw, and by tapering the rotor, you can ensure it stays attached above this surface and generates a low pressure zone, fully generating the lift in the screw along the entire surface. So with that knowledge, the final rotor is a single turn that stands 6.3 feet tall and starts at a radius of 2.4 feet, tapering out to that full 4.8 at the bottom. And when rotating at 360 RPM, it generates up to 152 pounds of thrust and requires 67 horsepower. And now that we understand the aerodynamics of the rotor, we need the structure to support it. So the rotor is comprised of a hollow aluminum shaft and 5 carbon fiber spars, which are each individually sized for the unique loading conditions they experience. And it's in a location where 2 carbon fiber helixes act as ribs as they sweep around. The spars are attached to the shaft through a titanium bracket, and the entire surface is wrapped in a high-performance sailcloth material. However, one of the most important concerns for any rotor, especially one as asymmetric as the aerial screw, is ensuring its balance. Due to the extreme height of the rotor and the asymmetric lift distribution due to the taper, the rotor generates very large 1 per rev inertial and aerodynamic moments. This caused many of our experimental rotors to break at the base of the shaft, and so we wanted to look into this very, very deeply. We were able to solve this by placing a centrifugal counterbalance to oppose this moment at the operating RPM. By placing about a 1/4 pound mass 1 meter from the shaft, we're able to effectively cancel all 1 per rev moments at the operating RPM. Now, the rotor itself is attached through a set of thrust bearings, lift struts, and flux couplings to a 2-stage gearbox, which is then driven by an MRAX 188 electric motor operating at over 95% efficiency. The motor is powered by state-of-the-art LiPo batteries, and this is all tucked into a nacelle directly below the rotor. Each screw has its own set of batteries to reduce the cable weight stretching along the arms. The gearbox itself is a double inline planetary gear arrangement, since the motor is in line with the rotor shaft, and it's designed to convert the 4,000 RPM at the motor to 367 RPM on the shaft, with a significant step up in torque. Each nacelle is then attached to an ultralight support arm consisting of the triangular configuration of an intricate pattern of carbon fiber cellular trusses. In all, each arm, although over 6 feet long, weighs only 15 pounds. And we have a detailed finite element analysis was performed to ensure that the factor of safety of at least 1.5 in buckling and a natural frequency of 2.5 per rev to avoid resonance with the rotor. At the other end, the support arms are connected to the central truss shown here. It's a triangle of aluminum tubing with bolted attachments to each arm. And directly below this central truss is the pilot seat. The pilot sits in a fully transparent cockpit directly below that structure and protected from the rotary downwash. In that cockpit, there's a multifunction display to input the waypoints pre-flight or to monitor Ellico in flight. And the pilot has a full field of view blocked only by the front nacelles, which can be augmented with external cameras. There's an array of cameras and sensors placed around the vehicle for safe flight and to ensure Ellico is aware of any obstacles on the ground or in flight. The central computer, GPS, and radios are housed in the central truss, and on each nacelle is Lidar for landing, IMU for vibrations monitoring, as well as sensors for the batteries, motor, and rotor RPM to provide feedback to the flight controller. And this flight controller consists of an inner loop for the attitude control and an outer loop for position control, which is fed by the pre-programmed waypoints in the path planner. And you can see below that there's little deviation from Ellico's flight, the dashed black lines, to the design mission, the solid lines. Overall, Ellico is designed with safety in mind. Its low disk loading allows for 25 knot downwash near the pilot and on the ground, which is equivalent to a strong breeze on the Beaufort scale. The monopod landing legs are designed to absorb up to 4G hard landing loads and a 1G side load. And the all-electric power plant reduces vibrations and improves the controllability. And lastly, in case of emergency, these motors can be driven to a zero torque state and allow, due to these large, heavy inertial rotors, an autorotative index of 27, exceeding requirements for modern helicopters. In terms of performance, Ellico has enough excess power installed to allow for rapid climb rates well exceeding mission requirements. The quad rotor configuration enables a CG offset of up to 1 rotor radius from the center of the vehicle. And while the nominal range of 74 meters is already nearly quadruple the requirement, you can trade payload for battery weight to give a maximum range of 311 meters. And if even greater range or endurance is desired, these batteries can be replaced with a turbo-electric generator to allow Ellico for hours and miles instead of minutes and meters. And additionally, as the aerial screw and other technologies develop, the modular collections allow for systematic upgrades. In conclusion, through a culmination of ultralight structures, efficient power plants, and a parametric study of aerial screws, Ellico revolutionizes Leonardo's initial sketch into a modern and incredibly capable design. I'd like to acknowledge all the help we received from our faculty members and fellow grad students at the University of Maryland that all helped make this piece of history a reality. And that'll conclude my presentation, and I'm happy to take any questions.
James, thank you very much. That was a fascinating presentation and a very interesting concept. What I'd like to offer to our members is, if you'd like to pose a question, what I'd like you to do is, you should have something in your control panel where you can write in a question as text, and I will pull those questions up and read them off one at a time. But in the meanwhile, I thought I'd start off with one of my own while we wait for our members to draft up any questions they have. We've actually got two. The first is, well, what was your motivation for selecting the Leonardo screw as your basic design? And second, were you to go into prototyping on this, what's the largest open question you have about the efficiency and the performance of your rotors?
So the first one, in terms of choosing the aerial screw as our main design, was prescribed by the RFP. The design requirement was that we used an aerial screw for lift and thrust, and so we designed to what the customer was asking. As far as going into prototyping and physically building this, beyond the 3D printed rotors we've already done, there's actually from this project now someone's working on their research, making a scale model of this. But the biggest question is actually ensuring that you have that rotor balanced. Right, we have the CFD analysis that shows where that vortex is generating lift. But how does that affect with a small amount of wind? Are you going to still be able to balance those moments well? So the early prototype designs are going to would be two-bladed designs so that you ensure that balance first.
Excellent, thank you very much. So I've started to get a couple questions, and I'll read off the name of the presenter and the member who asked the question, and then each question you can go ahead and field them. The first is from Scott Green. He asked, did you do CFD to analyze the vortex while in auto rotation?
No, unfortunately, we didn't have enough time to run that analysis in anything other than a hover condition. I'm sure in auto rotation, the flow field would be quite different as the air is traveling the opposite direction. But even less, these could act just as very large sails. It's just a very large surface area to drag on.
Right, thank you. Dan Curry wanted to let you know that he thought it was a great presentation. So that's not a question, but a comment. Thanks, Dan. Third is from Garrett Jensen. He wanted to know, and I assume he means what would be the cost of building Ellico? What was the cost of Ellico and how was it funded?
So if it were to be built, our cost estimate it was about 200 grand actually. So relatively inexpensive. That's, to be honest, mostly man hours of labor. The materials itself are not too expensive. And it was at such a cost that we've considered actually building it as a university project.
Excellent. And from our president, Mike Hirschberg, his question is, were you able to find any advantages from this blade configuration versus a conventional type of a rotor blade?
Advantages? One advantage we were looking into was the acoustics, as well as the downwash, just because it's such a large rotor with a low disk loading, that you would expect to see slightly lower noise and slightly lower downwash. But beyond that, no. I would say that over 500 years we have developed better rotors at generating lift. I can say that for sure.
Excellent, thank you. From Daniel Escobar, did you look at a rotor with 2 full revolutions?
We did in our experimental testing. We found that it didn't provide any meaningful benefit, or rather whatever benefit it did, it lost in its weight. We found that after 1 revolution, you started to lose the efficiency since the inflow was being blocked by another surface.
Let me ask a follow-up question to that, James, and that is, does airflow limit the sizing of your cabin cockpit? In other words, do you have to keep your usable payload, that cabin and cockpit, in a vertical space to avoid the downflow from your 4 rotors?
I'm sorry, can you repeat that? I guess you're asking, we just needed to make sure that he wasn't directly below the rotors?
Yeah, does that limit expanding the size of the cabin?
No, because then you'd just be able to extend those arms. Those arms are relatively light for every foot you extend them. It's, I think, 2.4 feet or 2.4 pounds per foot. So extending those further out doesn't add a lot of weight.
Mark Riddle would like to know if you could expand a bit on the sailcloth material that you selected.
I can't off the top of my head, no. I'm welcome to, I can get back to you with that, looking back on the report. I think the full report is listed on the VFS student design website, if you are interested. Actually, it might just be the executive summary post on there, but I'm happy to get back to you on that if you want to give me an email.
Thank you. I'll follow up on that for Mark. All right. That exhausts the questions that were asked. Do we have anybody else in our attendees who have any questions of James before we get him off the hot seat? All right. That looks like that's the last of our questions. James, thank you very much. That was the most interesting student presentation we've had since helicopter operations on Mars. I think it's tied for first among the ones I found the most interesting. Thank you. All right. And I think we're pretty much right on time to head into the next part of our agenda. I'm going to introduce our panel and talk a little bit about our motivation for pulling this panel together. The VFS is, a technical society to support the advancement of vertical flight. I know Mike's on board and I'm extemporizing, but or ad-libbing, I should say. But in the DC area, the federal city chapter is a bit unique in that, well, there's the seat of government and the seat of the U.S. military here, and many of our members, while some are within the, the academic realm, and some work on the technical side of vertical flight. A large number of our members work on the business side of the vertical flight industry, and specifically within military vertical flight businesses that service the U.S. military and their vertical flight needs. And so as a result, we like to, on a regular basis, bring a guest in that can talk about the military services sort of as the major end user of vertical flight technologies to understand what's driving the business side of the vertical flight industry. And so what I did was, get together with the chapter leadership. We had a discussion and we decided we were going to ask, the 5 military services of the U.S. to see if they could send a representative to come talk to us about, in very general and short terms, what the military services are doing to modernize their vertical fleets. And so we put this panel together. We're fortunate enough to have a representative from the Army, the Navy, the Air Force, the Marine Corps, and the Coast Guard / Department of Homeland Security. So I'm going to go ahead and introduce our panel. And then I'm going to give each of our panel members, approximately 5 minutes. They can take more if they need to kind of address their question. What is driving, your services future vertical flight modernization plans? Kind of an open-ended question. And then after each of them, provide us some opening comments, we're going to go ahead and let our members ask some questions. And then I'm trying to keep this entire thing to about an hour and complete by 7:30. If there's still have questions, we could probably push that to about 7:40, but not much more than that. And a little bit of chapter business we want to talk about at the end in order to complete by 8 p.m. So I'm not going to read bios per se, but I'm going to introduce our panel members. And I do believe we have all 5 on. So first, from the United States Army, from Headquarters Department of the Army, G8, which is Programs and Requirements, Colonel Lance Van Zandt. Lance is an Apache attack helicopter pilot, among many other things. And he leads the infamous Army G8 FDV, or Aviation Force Development Office. From the United States Navy, from the OPNAV staff N98, we have Captain Brian Ghost Binder. He's a branch head for Rotary aircraft in the OPNAV N98. Our third panel member is Major Jake Berninghausen. He works in the Office of the Assistant Secretary of the Air Force for Acquisition, SAF-AQ. Our Marine Corps representative is Colonel Chris Spinner Boniface. Works in the office of the in HQMC in the office of the Assistant Commandant for Aviation, working aviation programs and weapons systems and support assault support. Our last panel member is Captain Carl Riedlin. He is the U.S. Coast Guard's Chief of Aviation Forces in the office of the Assistant Commandant for Capabilities. And that rounds out our panel members. So I appreciate everyone's patience as we're working through how to do this as a webinar. I think so far we haven't had any major missteps. So I'm going to go ahead and ask Colonel Van Zandt, if he'd like to open the mic and get us started.
Hey, Rich, good evening. How do you hear me?
We have you loud and clear.
Okay, I'm attempting to get the webcam here to operate, but it doesn't appear to be functioning well. So I'm not sure if it's on or off, but we'll go with the voice only for now. If it works out, then we'll get some video. First of all, I just want to thank you for allowing me to be part of your panel this evening. And just going to James there, what a fantastic presentation as we kind of look back to the future, and a little bit of irony here as we're looking to modernize our fleet and at the same time have Da Vinci's dream come true there with flying. A couple of things. When you look at Army aviation and modernization, I had the privilege to be on the Joint Staff after Battalion Command, and one of the items in my portfolio was future vertical lift. And this is back in the 15 to 17 timeframe. We began to really look hard at modernizing our rotary wing fleet. Now let's, I just want to be clear up front. Right now with the Apache, the Black Hawk, and the Shook, which really make up the core of our rotary wing fleet, particularly for our conventional forces, they are superior aircraft. And if we go to war today, that's what we take. And I'd put them against any of our peers or near peers on any battlefield any day. That said, as we look forward and the evolution of battlefields and technologies, we've got to be able to increase. And the couple of areas we look at increased speed, range, increased lethality, increased endurance in and around objectives. And so those are some of the requirements that we've written into Army aviation as we look to modernize. You may have heard the bumper stickers of FARA and FLRAA. The Future Attack Reconnaissance Aircraft would be FARA, that's the acronym for that. And FLRAA is the acronym for the Future Long Range Assault Aircraft. Over time, we're looking to begin to substitute those into the force and eventually replace to a certain extent some of our enduring fleet. For example, the FARA is designed to get around a capability for that the OH-58 used to provide, that we're currently using Apaches for reconnaissance and attack missions. The FLRAA is going to be designed to replace a portion of our Black Hawk fleet, or at least augment and modernize. As of now, although procurement at some point will stop for the enduring fleet, it's going to be around. All those of our enduring airframes, Apaches, Black Hawks, Chinooks, will be around for the next 20, 30, 40 plus years as a part of our overall aviation fleet. Another tenet of this modernization effort is some of the enablers that we use on the battlefield and aviation as well, right? So we have, most are familiar with either the Shadow UAS, the Gray Gull, a little bit larger UAS. Over time, we're looking to modernize and replace those. Particularly, as we look at the Shadow, it's very capable. It's filled a gap reliably for a long time, but we're also looking at future UAS, and also what we refer to as ALE, air launched effects. So the ability to launch a reconnaissance asset or a sensing asset off of the aircraft once you're already out and to the forward area, to be able to launch from your aircraft and extend your range for reconnaissance and sensing out another 60, 70, 80 kilometers is something that we're looking at as well. So that's kind of where we want to go. And you look at that and you think about, hey, that's great, modernization sounds good. Let's go out and buy and procure these things. Well, there's a lot that has to happen between those visions and the actual realization. And one of the things that the Army's done, and this is somewhat of the how, over the past few years, the Army developed Army's Future Command. It's down in Austin, Texas, so it's a great place where industry, innovation, and academia are all very resident, and the Army is able to co-locate and tap into all of those resources. and look for fresh and new ideas as we begin to modernize. You couple that and what Futures Command allows us to do with some of our current acquisition strategies, and there's opportunity there for new and innovative ideas paired up with potentially faster sustainment models in some cases, or not sustainment, but acquisition models and strategies in some cases where we can actually accelerate getting these things onto the battlefield. And again, this will all be done in parallel as we continue to employ and use our enduring fleet, but also to bring along some of these modernization efforts moving forward. I'll stop there and turn over to one of the other panel members, but I'm more than happy to continue the dialogue on any specific questions. And I'll go as deep as I'm pretty much allowed to in order just to share the learning and cross-pollination to an extent across the group here. So with that, I'll turn it over to the next panel member.
All right, Colonel Van Zandt, thank you very much. I really appreciate, again, you being here and providing your opening comments. And we'll go ahead and turn it over to Captain Binder now from the OPNAV staff.
Thank you so much, Rich. Thanks, team, for taking us tonight. Carl, it's great to see you virtually. Sorry you can't see me. I'm having some web difficulties. Okay, I feel awfully guilty. Really, the reality is, Spinner and Carl, I don't have those awesome pictures that you guys have behind you, so I'm not going to show my webcam. But I appreciate the time with this group together. As Rich articulated in the beginning, I'm the Rotary branch head at N98. So what does that mean? So that means I've got responsibility for all my requirement officers for Rotary aviation across the Navy. That includes the MH-60 Romeo, MH-60 Sierra, the MH-53 Echoes, the Reserve Helicopter Force, as well as our unmanned MQ-8 Bravos and Charlies. So that's a huge force. Like to kid around in the office that I've got 50% of naval aviation, but it is a giant force. Part of my equity as well as Rotary branch head is the Future Vertical Lift Maritime Strike portfolio. Right, that is our piece of FVL within the OSD joint environment. So Navy FVL Maritime Strike is really, in our vision, a family of systems, both manned and unmanned. On the Navy front, we have completed our ICD, and it's been joint validated back in November of 19. From there, we've continued to participate, and even before that, in the joint environment with our joint partners, some of which are on the line here, and we continue to do that in the future as it makes sense across the board. We've also started early engagement with industry. We had our first industry day back in November of this past year in an unclassed environment. I thought it went up quite well. It's a first of future engagements. And oftentimes I get, well, why did you engage with industry so early? At this point, you're just a bunch of initial capability documents. You got nothing else going on, and you haven't started your AOA. Well, I think we would all agree on this line. It's never too early to engage with industry. It's never too early to get the conversation going as early as we can. So I think it was worthwhile. Plus, it led into the next part of the conversation with post that industry day. What we offered there was prepare for RFIs coming out to industry because we do have some work to do this year on the Navy front. We've got a material development decision that's coming our way, and we've got the start of our AOA process this fall. So in preparation for that, we've just this past week on the 28th of January, we released to industry our first unclassed RFI. We're excited about that, and it'll be the start of a multiple RFI process in the lead up to our AOA process, our analysis of alternatives this fall. This is critical to make sure that we've got the right injects before we start the AOA. As I started to talk about the AOA, it'll begin this fall and complete in the summer of 2022. Part of what we do is keep keen eye on our fellow services and see the work that's already been done. Some of it already articulated from my Army counterpart. For example, air launch effects. Those are things that are of interest on the Navy side too. So it's interesting that we talk about what's common across their services. Those things will help leverage and inform our own work in technology going forward. That being said, of course, the United States Navy has its own unique requirements and skill sets that we need to in order to support the Navy. A lot of that revolves around swap size and weight constraints that we have in a marinized environment that some of our service partners don't have to contend with in those areas. Well, we are keen to capitalize, of course, and find synergy with our fellow services as best we can, and in particular, our Marine Corps counterparts and spinners on the line with in particular, the unmanned components of those, because we share a lot of equities in that unmanned environment, as well as Carl, as we move forward, because we're a partnership in that marinized environment. We worked in that environment for years, and we will continue in the future. So we're excited from a Navy point of view. We're excited to start that industry engagement. I think you probably saw some open press articles. I mean, it's been cool. It's been a lot of Army over the last couple of years, and I understood why. I mean, you've got a lot of things going on, but finally, the Navy side of FVL, Maritime Strike, is starting to get some initial press, and I think we'll have that engagement, and particularly in the industry side, that's what we're excited for. This forum is one of those that I would love to continue to take part in, because it's important that we have dialogue along the way. Because I'll tell you, at our office, we learn just as much as you do in this dialogue, and I truly honor it in the process. So with that, I'll probably stop here. Just want to thank you, thank the presenter earlier on, great work, and thank the team here and the broader Federal City chapter of Vertical Flight Society for inviting me to speak on this panel tonight. With that, back over to you, Rich.
Hey, Ghost, thank you very much. I really, again, appreciate your being on board with us today and your willingness to talk. And yeah, I will echo what you said. And early signals to industry on what your desires are, helps industry frame, the IRAD plans and the focus of our own technical efforts, and frankly, our business plans. And so I applaud the Navy for diving in early and with both feet and engaging heavily with industry. And I'm sure most of our members will echo that same sentiment. So thank you very much. All right, next up we have Major Jake Berninghausen from SAF-AQ. Jake, you're on.
Awesome, thank you. Thanks for inviting me to this. I am a Vertical Flight Society member, so it's kind of exciting to be on this side of things. Many of you may not know that the Air Force does have helicopters. We got a couple. In terms of what's driving our modernization, I would like to say that it's the threat, but it's also, we've got some really old helicopters. So we do pilot training in a TH1, a single engine H model QE2. We still have just over 60 twin engine UH-1Ns from Vietnam. Most of them are 69 models. I think there might be one that's a 70. The CSAR force that does a lot of the personnel recoveries, they are flying 60Gs, which are modified Alpha Limas. Those are mostly early 80 models. Thankfully, we are starting to replace some of those. We are actually in the middle of two major acquisitions. The MH-139 is replacing our Hueys, and we're getting a brand new 60 variant, the 60 Whiskey, which is replacing our Gulfs. So that's the two main thrusts that we have. There's a lot of activity, which is abnormal for rotary wing in the Air Force, but we've got a lot of activity towards modernization right now. It's not FVL. The Air Force hasn't really been playing a whole lot in FVL, much to my dissatisfaction, but we've got different priorities, and I think we're looking for what's next beyond the FVL. It's the Air Force, so they want an F-35 that can land vertically. Not so much the C model, but something that has a little bit more helicopter-esque qualities to it that can also fly fast and long. And frankly, that technology just doesn't exist yet. We come close with the V-22, but as some of you may know, you can optimize a rotor for forward flight, or you can optimize it for hover, and trying to do both is difficult. So getting something that can do both extremely well is not quite yet in reach. So those are the big things that are driving modernization for us. the threat is causing us to look at different defensive systems. So we're upgrading our defensive systems. It's looking into the other threat, which is brownout landings. So we're looking into DVE solutions, and I know all the services are, and we're all trying to kind of piggyback on each other on a lot of these. There's a lot of joint effort going into it. But those are the big things that are driving it. I would also be remiss if I didn't mention Agility Prime. So you've probably heard of it. The eVTOL industry is really going crazy right now, and the Air Force is trying to get into that and try to inspire and enable industry in the eVTOL realm to help them with using our testing ranges, using some of our other logistics and certification resources to try and, one, grow that industry, find out how the military can exploit it and use it to the nation's benefit, and also keep some of that industry within our borders so that we don't lose a competitive edge. So those are really the big things that are driving the Air Force right now. We do have a smaller rotary wing fleet, but we are looking to reduce our dependence on runways, and rotary wing is really the best way to do that, in my opinion. So, with that, I'll move on so we can get to the questions, and I look forward to hearing what you guys have for us.
Excellent. Thank you very much, Jake. I appreciate it. And our next speaker will be Colonel Boniface. Spinner, it's yours.
Hey, good evening, and first of all, thank you for having me. This has been very informative so far, and I really was very interested in James Sutherland's presentation. I will say this to him: if he can get us to about 400 knots, about 3,000 miles, and a lot less gas, and keep it at about 200K a model, we need to talk. So that was really interesting. So first, ADCA, the Assistant Deputy Commandant of Aviation, was supposed to be here. He sends his regrets. He was unable. He's currently on travel. I am the Aviation Warfare Programs branch head for the Deputy Commandant of Aviation. So just a real 30 seconds of what I do. I handle every assault support platform in the Marine Corps. So the H1 program, the V-22 program, the 53 Echo Kilo program, presidential helicopter program. I do the C-130s program as well. I also handle, and I make sure that I kind of touch on this, is that I also handle aircraft survivability equipment, and I do a lot of interfacing with digital interoperability as well, and do a lot of survival equipment. Ironically, I just got handed that portfolio. So the Marine Corps has been in transition for about 15 years. We've transitioned every platform that we have from, and you know it off the top of your head, F-35. We're going to sundown the F-18 and the Harriers eventually. We sundown the EA-6B recently. The F-35 has sort of taken that place. We've also sundown the 46s and replaced it with the V-22. The V-22 is 32 years old. I hope everybody understands that. And I'll try to touch on that because there will be a replacement that's probably going to look something like a V-22 next. And I'd be interested to take some questions on that. But about a year and a half ago, the Commandant of the Marine Corps, General Berger, came in, and he took a hard look at threats. We've spent about 20 years fighting in Afghanistan and Iraq and in some of these other places in doing that sort of insurgency, co-insurgency sort of fight. We've sort of transitioned for that, and we're looking to the Pacific, in the Indo-Pacific now, and sort of this pivot to the Pacific. If you pick up the Washington Post, you'll hear that quite often. And we're looking at China. So a couple of themes that he kind of came in and looked at. He took a hard look at the national security strategy, the defense strategy, national military strategy, all the way down to the Commandant's own planning guidance. And then we created something called Force Design. Force Design was a look towards the Pacific, towards the Indo-PACOM theater, with China being our pacing threat. We've focused back on our naval expeditionary routes, getting close to the Navy again. We've sort of got away from that in the last 20 years since 9/11, and we are intending to address that pacing threat. we are going to evolve and innovate and get inside the first island chain, get inside the weapon engagement zone, and be able to fight that peer-to-peer effort. So my boss always says we're not necessarily looking at capabilities or not necessarily looking at platforms, we're looking at capabilities. So a couple things that you will see as we fight out there, and that some of the struggles that we are going through is sort of the distances, the first island chain to the second island chain or vice versa. As you look at China, tremendous amount of distance. How do I resupply a force? How do I maintain a reliable number of aircraft? Because as you get into the Filipino archipelago there's a number of things that become problematic that obviously we can't talk about on this net, but we kind of begin to look beyond airplanes to our capabilities. We started focusing, and we're focusing on long-range fires. We've kind of restructured how we look at the Marine Corps from the Marine Expeditionary Unit as sort of our maneuver element, our smallest of the maneuver elements, to the Marine Littoral Regiment and the Light Amphibious Warfare Ship, and redesigning Marine Infantry divisions and control and prosecution of surface targets. So there's a lot of stuff that isn't necessarily aviation related. So let me transition to that. We're looking to move, aviation has to be able to move vast distances. We have to be able to sustain Marines from vast distances. That takes a lot of fuel, that takes a lot of FARPs, that takes a lot of resupply. And with our different platforms, from using our F-35s as sort of that punch and that initial strike punch, to transitioning and still having the ability to attack through long-range fires, but also at the same time to be able to do logistics. And I will admit, I don't think we've had the logistics piece completely thought through. So the areas that I concentrate on are: one, reliability, availability, and maintainability of these aircraft. We have to be innovative as we sort of look to the future vertical lift, and we're in partner with the Army right now. And looking at that, we're also in partnership with our Navy brothers and sisters as well. And sort of that is the key that we're kind of struggling with as we go forward. V-22 is, like I said, 32 years. We're already looking at V-22 next and what that is going to look like. We would like to see an increase in speed. We would like to see an increase in reliability. We would like to see a decrease in the amount of fuel that we have to use. And I took a brief today that was probably one of the most innovative briefs that I've ever received on the future of that type of capability. We're also increasing our K1, and I'm a little bit over here, I got about a minute left, but we're also increasing our C-130 fleet to bring in on another squadron. We're bringing in the CH-53 kilos. So we are completely still in transition. I tell you, the 53 kilo is going to be a game changer, I believe, is the only really heavy lift helicopter that sort of exists in the free world besides the 47. And the Army and us can go back and forth on which is better. But those are some of the keys to it all. But what I would like to kind of finish up is that we get these kind of increased distances, reliability, availability. We still have to be able to defend ourselves. And I think we've sort of gotten out of that in the last few years, as we kind of, our biggest threat was the random manpad shot or RPG shot or small arms fire that we all dealt with. But it is actually transitioned to some fairly peer-to-peer serious threats that we have to be able to defend ourselves from. And at the same time, we have to be able to communicate. And so all our platforms are looking at the Link 16 and some of these other communication platforms that we're going through. And that, I will say, is we can talk about rotors and motors all day long, but it's going to be very critical that we have a reliable aircraft that can defend itself and that can actually talk to one another in incredibly long distances. While obviously wearing this uniform, we support the grunt and the Marine on the ground. So with that, I look forward to your questions, and that's all I have. Thank you.
Ms. Bitter, thank you very much for your comments. Again, I really appreciate your being here with us to talk to our members tonight. And I can only begin to appreciate the challenge you have in HQMC and managing the diversity of fixed and rotary wing fleets that that the assistant commandant, the deputy commandant for aviation is charged with maintaining. It's mind-boggling. Having sat in Colonel Van Zandt's seat a long time ago, when times were easier, not so complex. Although those fleets are large in numbers, it's a less diverse fleet in terms of the numbers of MDSs that you have to manage. So my hat's off to you for the hard work you and your teammates do up there in the deputy commandant's office. All right, just one quick reminder before we go to our last speaker, and that is there will be a Q&A period, just as we had for James's presentation. So those of you that are thinking of asking our panel members questions, feel free to begin teeing those up while our last speaker talks. And our last speaker is going to jump on board right now, and that's Captain Carl Riedlin, the U.S. Coast Guard's Chief of Aviation Forces. So Carl, take it away.
Well, I certainly appreciate you all leaving the best service for last as we talk about the future of rotary wing and vertical flight. It's a real pleasure to be here. And certainly, Rich, I appreciate you asking for our involvement in this. As anybody that knows or turns on a TV show, vertical flight, vertical lift, helicopters is an absolutely essential part to what the Coast Guard does, the protection that we provide to the nation, both from a search and rescue standpoint and use across the 11 statutory missions that we do, ranging from military operations with our joint partners to to the law enforcement that you see happening down along the East Pac, the Caribbean, and trying to stop the flow of drugs into the United States. So to give you a little bit of background about how the Coast Guard is structured, it is true there is a captain that runs aviation for the Coast Guard. That's it. That's where the buck stops. And that's the advantage of being small, and it's the disadvantage of being small because we've got about 200 aircraft and about 5,000 people spread out over 26 air stations, and so a lot of activity going on there. And one of the things that we do to attempt to work across such a broad range of areas. So we're flying in the Arctic, we work in the mountains, we do inland search and rescue, we go all the way down into the East Pac, the West Pac, the Caribbean. We've got ships that operate out in the Persian Gulf with helicopters on the back. We've got folks that are over in the West Pac as well on back of cutters. So imagine having to figure out how to use vertical flight in the Arctic, the expanses of Alaska. It's got to fit on a ship to be able to operate, and we've got to be able to operate in hot, humid environments and also at altitude. And so all of the challenges that the other services are throwing at the engineers throughout the world and the really smart people that can make these things happen for the operator are exactly what we need. The bigger part about it is now imagine going out there almost on a weekly basis. You take a person, you throw them in the water, you pull them up out of the water, and they drain a whole bucket load of salt water into your aircraft, which rests on the bottom of your airframe. And you spend almost all of your time within about anywhere from 300 to 150 feet from the surface of a salty water environment. And there lies our challenge in the Coast Guard. What you'll find in the Coast Guard for us is we really rely on our DoD partners for the innovation when it comes to airframes, power plants, and things along those lines. We work very, very closely with them. Where I believe we contribute in an enormous amount is how do you preserve an aircraft in a saltwater environment? What type of corrosion, and then how do you get an aircraft to last a long time out there? So the Coast Guard's environment, we fly about 700 hours a year on our aircraft. We've been flying the H-65. We have 146 rotary wing aircraft, 98 H-65s, which is an Airbus S365 variant business aircraft that we incorporated into a military and Coast Guard application, and then also the H-60. And for us, the H-60 is the cousin to the not the H model, but the Foxtrot and the Hotel model for the Navy. And so when you think of a Coast Guard H-60, they were built on the same line as the Hotel model for the Navy. Our strategy and modernization efforts right now in the Coast Guard are driven primarily on the needs of the service, which is, getting offshore, that endurance, that ability to spend time in a search pattern, and then that presence out there. But bigger is being driven by the fact that we're in a major modern recapitalization of our cutter fleets. And so you can imagine a small service with cutters that are 400 feet long that we're trying to build, and the costs associated with that as we modernize our cutter fleets. The heart and soul of our aviation program when it comes to the ability to keep them flying is a place called the Aviation Logistics Center down in North Carolina. We have sort of a motto in the Coast Guard: never pass up a yard sale. And we can take somebody else's used equipment and make it work even better or longer. And we can figure it out because we've got such a fantastic group of artisans. We've got some engineers down there. And to be honest with you, the partnerships with Pax River, we work a lot with Pax River and also with the OEM. We have got a major service life extension program in both of our airframes going on. So all of our aircraft right now are approaching the 20,000 hour range. If you take a look at how we burn through an aircraft, like I said, it's about 700 hours a year. We rip through them very quickly. We're in a process of doing a service life extension on both the 65 and the H60 to get them out to 30,000 hours, and we're going to try and get to around the 2040 timeframe. We work closely with, I'm part of the Joint Council of Colonels for Future Vertical Lift, and we are super excited about what the Army's working on. We're super excited about what the Navy's working on, and really interested in what the Marine Corps is working on when it comes to FLRAA, and most importantly, the Maritime Strike Aircraft as they come forward. We are contributing by bringing in our requirements, but our requirements are a little bit simpler than the other services, so we try not to hinder them with very specific Coast Guard requirements that might deviate from our ability to do national defense missions with the aircraft. So our focus has been on this: how do we get airplanes to get to a modern, or get to the next generation of future vertical lift? And in the 65 world, that is a Rockwell Collins glass cockpit. It's modern communications, and it's structural enhancements that we're doing down at ALC right now during the overhaul. One of the methods we've used to keep aircraft flying as long in a saltwater environment is every 4 years we bring the aircraft down to parade rest, we tear it apart, we replace fittings, frames, upper shear decks, a pretty extensive amount of work, and then send it back out to the field to work. We use that same line to do the service life extensions and the modernization programs. For our H60 fleet, we had lost several aircraft due to crashes, and due to the generosity of the Navy and Pax River, they gave us initially, back in 2005, they gave us a Foxtrot haul and said, hey, this thing's got 2,000 hours, we're not using it, not sure if you can how you can use it, and we were able to make the changes we needed to do to the aircraft to make it almost identical to a J haul. And then the Tango conversions, which we were in the process of doing a glass cockpit upgrade back in 2008 timeframe, and produce a hull that looked just like a Coast Guard aircraft, and we built all the tech packages off that. The advantage there was all of a sudden the Navy was starting to sundown their aircraft. And I remember working with Ken Conigli at a PMA 299 about a billion years ago. And he called me up and he said, what do you need as we sundown these aircraft? And all I could say was, fly me them in whole, and we can go from there. So right now, our SLEP for the H60 is taking Foxtrot and Hotel sundown Navy aircraft that have about 8,000 to 10,000 hours of life on them. And then we're gonna do a modification of the aircraft, put the structural enhancement kits that we've developed over the years with the OEM to extend the life of the aircraft to get to 20,000 hours. Now, it even gets more exciting because Lockheed Martin got involved and said, hey, we can build new hulls for you. What do you need? And then they actually took our work with the Tango modifications for the H60, took the tech packages, and they're going to start producing brand new Tango hulls for the Coast Guard that have a 20,000 hour life span on them. And so really a lot of really exciting things going on with that. You can imagine also sensors and how do we utilize the aircraft. We're working now to try to get a 360-degree radar system on our H-60, and we're working towards better shooting platforms and things like that. So, you know, the aircraft itself, yeah, sticking around. Lots of interesting engineering on how do you make an aircraft stay alive for a long time. Advances for the modern cockpit for the crews, and then adding to the sensor packages and then linking all of those together so that they can communicate. If you can imagine a Coast Guard world, Coast Guard crews operate single ship up to 300 nautical miles away from any landmass. We want to create an environment where they're actually in a teaming environment and they're able to communicate through sensors and the right type of avionics on the aircraft. So with that, I'm gonna stop there. I think there's a great future, and we really really appreciate the partnership between the different services, because we certainly would not be able to do what we're doing in the Coast Guard without that help.
Carl, thank you very much. That was an excellent run through of the challenges you face, and I think added to that are a couple more that popped to my mind. The first is that, you know, your operational footprint is extremely large, especially given the size of the force that you're dealing with, and the fact that, you know, every day you're deployed. All right, I mean, your fleets are your aircraft fleets are out there, and any day can be an unknown operational challenge. And I think it's remarkable that you managed to keep those fleets in shape and keep your folks trained when you have those challenges. So thanks for joining us today. Thanks for your comments. All right, looks like we got some questions queued up. What I plan to do is go ahead and read them off. Some are meant for individual panel members. There's at least one in here that asks for a comment from each of you. And I'm going to go ahead and do the Q&A through about 7:40 if our panel members will hang with us, since we have quite a few questions keyed up, and that'll leave the remaining 20 minutes for some chapter business. So let's get right into it. Ghost, first question's for you. It's from Steve Trimble, and the question is, how is the Navy at this point valuing speed relative to endurance for maritime strike?
Thanks. Great question. You know, the easy answer from me is endurance will be valued over speed. We're going to need ISR&T is going to be critical as we move forward, and part of that is some loiter time and maintaining the capability up there. Doesn't mean that speed's not important. We're always going to be asking and reaching for more, but if you put it on the line and which one you need more, we're going to need some more endurance, because we need that stay time, especially in a DMO construct. Thanks.
Excellent. Thank you very much. All right, from Scott Green, this question, Colonel Van Zandt, is for you. How do you see autonomous flight or automated crew tasks having a role for modernization of your fleets?
Hey, I appreciate it. That's a great question. It's something that we look at closely as autonomy begins to evolve and become a greater part of what we do. As you know, we use you know, our unmanned systems, and when we look at future vertical lift, and I say unmanned, just, you know, again, specifically think Gray Eagles or the Shadow UAVs. As we look at future vertical lift, while all of those right now we're building manned systems, we're also looking at optionally manned systems. So, you know, the ability to potentially fly some of those aircraft, you know, unmanned, and depending on the mission set they may be being asked to do. From an autonomy perspective, frankly, I don't think we're there yet for some of our bigger mission sets, but we are looking at autonomy in some of our AOE. And when I mentioned FARA earlier, I think Ghost mentioned family of systems for the Navy. Well, we refer to the way FARA, Future Attack Reconnaissance Aircraft, will operate as an ecosystem. So we commonly say, you'll hear us talk about the FARA ecosystem, and that is some of those autonomous, like the air-launched effects, for example, we can launch out and it can conduct missions on a semi-autonomous basis. But I'm kind of dancing around, but I hope I provide you enough that something we're looking at and exploring. And in some cases, the technology just isn't there yet to fully employ.
Thanks, Lance. Appreciate it. All right, so back to Spinner. This is from Steve Trimble. His question is whether the Marine Corps has any interest in re-engineering versus replacing the V-22 to achieve the additional speed and fuel efficiency you're looking for.
Yeah, so it's interesting that you say that. So we are, so there's V-22 and then there's FBL. I will say that V-22, the MV-22 as a platform, 32 years, we are looking at the initial V-22 next. We have done a study. I've got the first study. We're going to roll it out as an industry day in March. General Mazziello, who's POA, Aircraft Systems out there at Pax River, is going to do that. But long story short is this. We've looked at different courses of action through a study. Some are very, very expensive. Some are not so expensive. Some kind of fit it right into our wheelhouse. But bottom line is this. V-22 next. We will have to look at increasing the reliability, the availability, and the maintainability, sustainability of that airframe. What that looks like, we're not necessarily quite sure. I will say that everything that goes into those nacelles, I would like to see sort of redesigned at some point, and we're in the middle of maybe doing that. I would like to see us sort of begin to look at some very high speed VTOL, increasing in our range. And, as General Wise, my boss, says, gas is a real issue. And so anything that we can do to increase the fuel, the economy sort of fuel availability to the grunts by sort of being a little bit more fuel efficient with what we're doing. And I know I just asked for everything. I trust me, I get it. But that's what we're kind of looking at for the future. So we're not sure if it's going to be a brand new aircraft or if it's going to be something that is sort of re-engineered. But we're working a lot with our Air Force, with the Air Force as well, and the Navy just is replacing their COD with it. So there's going to be a lot of decisions to be made over the next probably 5 to 8 years of where we see that platform going. Hope that answers your question.
Thanks. I'm reading these questions in the order in which they were posed. I thought that would be fair. And the next one almost kind of works out as a follow-up to the previous question to you, Spinner, and has another piece in there. What can industry do for the Marine Corps as you develop your requirements for V-22 next and for the replacement of your H-1s?
Yeah, it's interesting. I'm glad that somebody asked that question, because I think, Rich, you said it best when you said early signals to industry. Sometimes industry comes in and they sort of are apologetic, like, oh, we don't want to bother you, we know how busy you are. Look, as far as industry is concerned, call me every day. Come and see me all the time, because I like to sit down and almost have like war college type seminars of discussions about where we're going. I know that comes with a TOA stream, or a total obligation authority, but which is not necessarily all there right now. But industry is highly, highly important to me, because one, what I say to industry is what I say to the deputy commandant. So I'll always be honest with you. But I also want to throw different ideas out there. It's like, hey, look, with this force design, it has been such a new concept for the Marine Corps. It is forcing us to look in areas that we haven't looked at in 30 years or even longer. It is forcing us to use our critical thinking skills. And to be perfectly honest, sometimes we need a lot of help in doing that. So all these things from FARPs to how do I supply a Marine littoral regiment? How do I get inside a weapons engagement zone and remain survivable? I need help with that. And so there are many times when early signals to industry are incredibly important. For H1, we will have to replace those platforms, although we're still procuring them. but we do see a sunset at some point, and we do, like we said, we're in partnership with the Army as well for FVL and FLORA and ORA and FARA and all the other things that I get confused. But it's very important to have an early, open, and frequent dialogue with industry. Although there's no promises that I can make, it's important because you need to know what we're thinking, and this is a very transitional time for at least our service, and I'll even roll in the Navy in that if I can speak for them, because it's just very critical right now that we get ahead as we shift to that peer-to-peer threat.
Thanks, Spinner. The next question is sort of to any panel member, so I'll throw it out there, and if you have a comment to make, just go ahead and jump in. And this is from Mark Riddle, and the question is, and I'll paraphrase Mark's question just a touch. Where do you see the common needs are that enable both your current platforms and your FVL platforms to operate in a joint all-domain environment? I believe what he's asking is, where are your needs that span both the existing fleets and the future fleets to be able to operate in that future operational construct?
I'll take a quick shot at it, and this may be only a partial answer, but I think somebody had mentioned it before. They mentioned Link 16, and I know with the new JADC2, the Joint All-Domain Command and Control system that the Air Force is working on, connecting all of us so that we all see the same battle picture. We all know that, this little green helicopter is a good guy and this red one's a bad guy. And we all see the same thing. So that's not always the case when you get into the fog of war. So getting that interconnected data link that we're all seeing the same picture in the air, on the ground, and we're all talking the same language. That's going to be probably one of the biggest things that can help us right now, and we will need it definitely in the future. Other than that, basic things, a solid DVE solution, dust is not going to go anywhere, so we're going to need that. And then more advancements in autonomy that may help in the dust situation, and may also help to reduce our dependence on pilots. As the threats get even more deadly in those peer environments, that maybe we cannot defeat them completely. Maybe we don't want to risk sending, actual people in to do some of those missions. And if we can do them autonomously with hardware that can be replaced, then I think that would save a lot of money, a lot of training dollars for sure.
Thanks, Jake. Would anyone else like to take a stab?
Sure, I'll jump in. The Coast Guard will jump in. I think what's important from our perspective is to be aligned with the Navy and the Marine Corps as we move forward, especially in how we missionize our aircraft. And so, we're using the same systems that the Navy's using, the Marine Corps is using to connect sensors and transmit and report, send data out in there. And I think that interoperability is going to be really important. In the event that there's ever really a peer-to-peer type confrontation, we all play different roles and we all have areas that we can work in. One of the advantages for the Coast Guard is that we are not as threatening to other nations. And so we have the ability to partner with Russia. We have the ability to partner in the humanitarian side of it. But at the same time, we also need to be ready to stand in a military stance and be able to augment in those areas. And so I think the interoperability is going to be essential. And then when you talk about platforms, as we start to bring new platforms in, that have speed and they have range and they have all these other things, we have to recognize that we're going to be using our current legacy platforms in concert with that. And so how we place those, how we distribute them, and how we have those operate with each other, I think those are all key elements.
Hey, Mark,
Yeah.
I think, as we look to the future and the technologies and capabilities bridge our way there. We've got to remain lethal, and we have to remain survivable on the battlefield. And I know as a former Apache guy, you speak that language. So our weapon systems that we develop now, even as we look right now at long-range precision munition solutions to potentially go on, far FLAR in the future. Well, they need to be able to be used and backwards compatible, most likely, with an Apache as we move forward. The same thing with some of our aircraft survivability equipment and gear. We've got to continue to evolve and mature those capabilities to counter future threats as they evolve as well, and then a way to transition that kit and equipment to the new fleet of aircraft as they come online. So those are probably two that come to my mind as an attack aviator, in addition to the ones that I already mentioned.
Thanks, Lance.
And Rich, let me just, this is Ghost, let me just capitalize on what Carl talked about earlier. And we talk about the environment. It's really important for us, particularly, Coast Guard, well, for all players here, but in the marinized environment, it's not like we're going to flip a switch in 10 years from now and we're going to have a whole new set of ships and a whole new new set of aircraft to go with them. We are going to be living this over the next 20 years. I commanded an amazing squadron and flew the MH-60 Romeo. That's an amazing aircraft. I'm going to have that aircraft for the next 2 decades. That aircraft is going to be there when FBL maritime strike, man-to-man, will be in the system. Same thing with our surface brothers and sisters. The ships aren't just going to go away. The existing Flight 2s are going to be out there. As they grow their fleet in the future service fleet, they will enter into the fleet over the coming years, but it doesn't turn the switch. So it's vitally important that there is a connection between legacy and the next generation, but we expect the next generation to be that much more potent, right? It's got to be able to connect it. What would be great is if all of our unmanned type systems were interconnected as well in more of a joint environment. And one other thing to consider too is we can't overcomplicate this thing, because at the end of the day, I live at sea, and if I can't get it supplied, we can't get anywhere. So the supply chains, the supply lines, we cannot overcomplicate this process, or we'll shut ourselves down within weeks. Thanks.
Thanks, Gus. All right, next question is directed to Major Berninghausen. So Jake, you mentioned DVE threat is a large concern. Scott Green would like to know if you can speak to your current efforts to solve the DVE brownout problem.
Yeah, so currently, the people that have the most problem with the brownouts, at least in the Air Force, is our H-60 drivers. The H-1s don't really have to worry about it too much, maybe whiteouts. And the V-22's got a fairly good flight control system that they've got some decent mitigations currently. So right now we're exploring a solution from Sierra Nevada. It's not their top of the line model, but it is something. It's better than what we've got, and we're doing an install on some of the 60Gs that are going to stick around a little bit longer than the rest, just to kind of feel it out. And based on that effort and the feedback we get from the field, we're going to evaluate what we want to do for the 60 Whiskey. So I imagine, and this is speculation on my part, that it's going to be some type of system with at least a Lidar and a millimeter wave radar that can give the pilot at minimum visual feedback, if not integrated into the flight controls, so that the aircraft can do the approach itself. But that's kind of what we're looking for. We want something that the pilot can overcome if they need to, but it's going to keep them safe, and it can build off of not just existing terrain data, but also real world obstacles that may move into the landing zone as the dust cloud is forming. Yeah, I don't know if that answers the question, but
I think it does, Jake. Thank you. All right. Next question is from Frederick Sy, and I'm just going to go ahead and lay this out to anybody who would like to take it. I think anybody but Colonel Van Zandt, because it's about what the Army's been doing lately. So the way FAR and FLORA competition has been going so far, and I think he's referring to the GMRTD for FLORA that led up to that effort, and the ongoing effort to develop prototype aircraft for FARA, you know, ahead of a final award. Is this the new normal, to develop proven, demonstrable vehicles before awarding procurement contracts?
Rich, did you say that was for me or for anybody but me?
No, I jokingly said it's anybody but you, but really, Lance, if you'd like to field that, you're welcome to. The Army is kind of leading the DoD on this strategy for weapon system development.
Right. So I tell you what, it's been an incredible partnership, you know, with several vendors throughout, you know, in industry, and as everyone knows, we about a year ago that was narrowed down to two. So you've got Bell and Boeing Sikorsky, and I believe your pictures there, the folks can see them. You've got, it looks like the Valor 280 and the from Bell on the bottom left, and the bottom right you've got the Boeing Sikorsky Defiant. And I think there's folks that represent both those organizations in the audience tonight, so they can correct me. But
you certainly do.
Yeah. So what that has done is it's allowed us to mature and evolve the requirements and what's actually possible. You know, what was a vision on a chart that had capability sets 1 through 5, generally going from a smaller rotary wing replacement all the way up to the replacement of a CH-53 size aircraft, has matured now into aircraft that can perform, frankly, the majority of the requirements. I think in some cases you don't really get to all of them, and in some places there's trade-offs, but the partnership has been I think a faster acquisition process, and it's also, you know, allowed industry to be involved and again to form requirements, you know, throughout in a more iterative versus dropping a piece of paper and then waiting years and then coming back and re-looking at it. So I think it's been great. We'll see how it works out in the end, and it may in fact be a model that the other services can look at as well. And not to, you know, sit here and filibuster, but another thing we're doing is a buy, try, and form strategy. So for the shadow replacement and our ground brigade combat teams, we're looking at there's 4 different vendors out there that have all produced a product that we put out in the ground brigades, the brigade combat teams, about a year ago. And all of those have done just numerous, they've done everything from CTC relationships to home station training, et cetera, just to test the employment of those systems, how effective they are. And they're actually doing a quote unquote future tactical UAS rodeo down at Fort Benning, Georgia, late February, first week of March. Again, that's a buy, try, and form process where we've just bought some equipment and we're trying to inform what's going to be the ultimate replacement or augmentee for shadows and the ground brigade. So there's a couple different strategies out there. We're looking to shave some time off of the, you know, inception to realization of a, you know, product procurement. Over.
Excellent. Would anyone else like to take a stab at that?
Yeah, I mean, I'm going to jump in if I can real quick. I think it's just incredible. You know, when you look at the talent that is out there in industry and the innovation that's out there in industry, I mean, we're in an incredible place. You know, if the Coast Guard, if industry and really those pioneering inventors that had ideas on what they could do, we'd still be flying boats around trying to do rescues offshore if it hadn't been for an Igor Sikorsky that said, hey, I can take this thing that looks like a kite, looks a little bit scary, but I can hold it over one place and we can rescue people. You know, we certainly wouldn't be in the place that we are right now. So I think to me, it was groundbreaking when we watched helicopters go fast. It was amazing watching the Marine Corps through absolute thick and thin stick with the V-22 and actually make tiltrotor a reality in the coast, in there, and then watching the Bell Boeing team, work on that. So, you got really innovative designs on how you can solve a problem, which is, that retreating blade stall, and it's a pretty neat stuff. So I'm impressed.
Yeah, as they say, the design space was wide open at the beginning of the JMRTD, and it is remarkable to see how far these technologies have advanced in a decade. All right, we have 10 minutes. If panelists stick with me, we're going to get as many questions as we can in before we hit 7:40. So the next question from Mark Riddle, and for all panel members, since the Army's got the lead for Cape Set 1 with FARA and Cape Set 3 with FLRAA, who do you see as taking the lead for the capability Set 2 FVL development?
Well, I'll quickly jump in on this one, Rich. This is Ghost. Cape Set 2 is right in the Navy's wheelhouse for size and weight constraints. So we've been living in that arena here for a little while within the joint environment for FVL. And obviously staying tuned what the other services are doing with similarities across. When we already talked about air launch effects, aircraft survivability, modular open systems, modular payloads. All these things are going to be integral across the services. But I know where the Navy is, and Navy is sitting in that Cape Set 2 arena. Thanks.
Excellent, thank you. All right, so Carl, this next one's for you from Scott Green, and that is with your 60 fleets being extended in terms of range, are you planning on taking advantage of the ITEP engine?
I love that question. And right now, we have been waiting for the ITEP engine for the last 10 or 15 years to watch the development on it. We don't have a current acquisition to re-engine the H60, but the capability that the ITEP engine would do to an H60. So the Coast Guard H60 is the longest range H60 in the world, and it's because we forfeited a bunch of cabin space and we carry a bunch of gas with us. And so, we're going to be flying the H60 for probably the next 20 to 40 years is what we're anticipating. In some version, some way or form, one shape or form, we're going to be in the H60 business for a while. The ITEP engine is just incredible. I mean, if you can get, an increase in power, a fuel reduction, I think Spinner hit it well. I'm asking for everything in the world. And in this case, with the ITEP engine, you're giving it to me. And I can really take a platform and make it even that much more capable. So in the short term, no, we're trying to get through the SLEP. In the long term, I think the ITEP engine will play a future in the Coast Guard.
Excellent, thank you. All right, next one, and this is kind of an open one from Shelley Yarborough, and that is, would any of the panel members like to who have not already commented on emerging UAS requirements, would like to talk about that, especially vertical takeoff and landing UAS requirements?
Do you guys mind if I jump in? So I think it's a really interesting, an awesome question on it. And, UAS is a huge spectrum, right? So you've got the long range, long endurance, and you're going to get a winged aircraft that's going to do that for you. Where I think the vertical piece to UAS becomes so important is when you are space and weight constraints. So Ghost had mentioned earlier that, hey, that Cape Set 2 is the Navy's wheelhouse, and we are really, really interested in and willing to work with the Navy and working with the Navy on what that Cape Set 2 looks like, because we've got to put helicopters on the back of cutters. We also use UAS on the back of cutters. Our current UAS that we use right now on a cutter has a catapult system. It launches it out, and then it's got a snag system that catches it. And although not elegant, actually works extremely well. But you can imagine the footprint that it takes in an aircraft, in a ship, to carry a catapult system, to carry the recovery system on board. And so I think it's the space constraints at sea that really the ability for a vertical takeoff UAS that has some endurance and some range is just gonna play really, really well in the future. In the cutters that we have UAS, they do not like to go out to sea without the UAS on it. So the UAS is a big part of I think anyone's suite of systems.
Yeah, also I'll comment on that. So I don't actually own the UAS platform at headquarters Mercury Aviation, but what I'll say is, you know, we had a big discussion on it today, and I think if you've heard sort of the themes that I've thrown out there with force design and sort of this first island chain and inside the weapons engagement zone, there aren't necessarily a lot of areas to throw down long runways or do some of the other things that we were doing. But I will say that vertical takeoff and landing is critical. I will also say that I feel, and this is just a little bit of a difference from the Navy, is that the speed is still somewhat critical because the endurance is critical, if that makes sense. Get to the fight, get your endurance, increase your endurance, and then come back to your platform, whether that's a DDG with a type of UAS that can fit inside a hangar or whatever it ends up being, and come back and land. So I will say it's highly critical, and it's something that it's an ironic question that was asked because it's something that we are looking at pretty seriously, at least for some of the CubeSats as we go forward. If that makes sense.
Thanks, Ben.
I might have failed to mention, Rich, for the Army, all four of those vendors produced a vertical takeoff and landing system that are runway independent. That's the way we're moving forward in our brigade combat teams.
Excellent. Yeah, especially critical given how your BCTs operate well forward and runway dependent UASs are a challenge. We have a couple minutes left. I'm going to go one more question and then give each panel member some final comments. Last question comes from Lacey Coleman, and this is for you, Carl. She said she's always amazed to hear about your organic capabilities at your aviation logistics center. Can you comment on some of your biggest challenges as you convert your 60 hotels and SH-60 Foxtrots to extend the life of your fleets?
Sure, absolutely, Lacey. Thanks. It's good to hear that you're out there. I'd like to say that was a softball. If I had my counterpart, I've got a close friend and colleague, Ken Everingham, that's actually the chief engineer for aviation in the Coast Guard, and he really is the one that is working hard to make that magic happen down there. You know, in the past, I had a chance to work down there as a product line manager many years ago when I was a little bit younger, and I was actually the H-60 product line manager. And you know, we would get a lot of questions from folks, you know, working with the DoD and stuff that would be like, why does the Coast Guard have an overhaul facility? And the truth of the matter is, Coast Guard Aviation started with, hey, we've got these old aircraft, we don't know what to do with them. And so we had to develop that skill set and that capability over the years. What we found is that it really allowed us to fly aircraft where in the environment we're flying in, we would probably only get about 10 years out of an aircraft, and we can extend that to 15, 20, 25, 30 years because of the overhaul capacity. Lacey's team and the Lockheed Martin team really came in and have helped us out tremendously as we are doing the service life extension. So our plan for service life extension was to take Old Navy aircraft, do the Coast Guard magic down at ALC, and make a haul that could go to 20,000 hours and fly that aircraft into the future. And we are doing that, and we are planning on doing that. But their team came even one better and said, hey, you know what, we can build a new Tango hull, which is the same hull that you had built 30 years ago, that meets all of the spec and requirements that you have for your glass cockpit and the modifications that you've made over the years. And so I think that technical exchange has been really important. I would also say that one of the things that we've really done, I think, well in the Coast Guard and out of necessity is we've always had a very close partnership with the different OEMs. And so each one of our airframes are maintained down there. They go through the overhaul every 4 years, but our engineering is really tied with the OEM as we make modifications and changes to the airframes. So, you know, that successful partnership. Challenges, absolutely. We can only produce so many a year, and that system is critically tied to our depot overhaul system. And so, like I said, the hulls that Sikorsky is building for us right now for the SLEP program is going to be really essential for us as we move forward. I don't know, Lacey, did I get it?
I'm not sure we can unmute Lacey, but Lacey, if you have a follow-up for Carl, let me know via text, and then we'll move on to our roll-up here. I happen to have Lacey up on a company text right now.
Okay, if you'd like, I can also unmute him or unmute her. My apologies. So if you all would like, I can.
She says you nailed it.
Oh, perfect. All right.
All right. Hey, this completes our Q&A. We had a few more we could go on all night. I don't want to do that to our panel. So I want to offer each of you sort of a 60-second summary, any final comments you may have for our membership. And I'm going to start this in the reverse order. So we're going to start with Carl. Any comments, final comments? You got 1 minute.
I really appreciate the audience. Really appreciate the innovation out there. I love the fact that the services all play sort of a different role. I think where we've been able to help out, we can't help out with the big engineering strengths and the big dollars, but we can get stuff on aircraft a whole lot quicker to test than anyone else, because there's literally about 3 people that we have to ask. And so we really play off each other, I think, incredibly well. And again, those partnerships are critical for us. So between industry and the other services. Thanks. Thanks,
Carl. Spinner.
Well, first, thanks for having me. I really appreciate this. And the takeaways that I would have is that we are looking at a peer-to-peer threat as we sort of shift and pivot to the Pacific. That comes with sort of an increase in innovation. And while we're looking at a lot of things, it's going to take a while to sort of achieve that sort of nirvana that we want to get to. But anything that we build, we have to make sure that we're being extremely innovative. And one areas that we haven't talked about tonight is sustainability and maintainability. It's got to be sustainable and maintainable. And it's got to maintain its reliability, because as we get into these extremely exquisite and very, very expensive platforms that sort of provide a capability, that's truly where we have to sort of focus, is being able to compete, and I say compete at that peer-to-peer level. But thank you very much for having me. I really appreciate it.
Thank you. Jake, your turn.
All right. So yeah, I want to also thank you guys for giving me the opportunity to come here and speak to you. I echo a lot of what my fellow service members have said. We face a lot of maintainability issues, and as these aircraft get more and more expensive and more technically advanced, that's only going to get worse, I think. So I guess I would look towards the Vertical Flight Society membership to be the source of a lot of the innovation. I've been to the forum before. It's awesome. You guys are really on the cutting edge of what's next. I would encourage you to keep trying, fail quickly, fail often, bring those ideas to us, and hopefully we can, insert some of the limited dollars we have into those and make things better. But the reality of the world is we're going to have to improve. We're going to have to take those next generational leaps if we're going to continue to be the country that we are. So thank you.
Excellent. Thank you very much. Ghost, I think you're up.
Awesome. Hey, Rich, great job to your entire team. It's fantastic panel tonight, fantastic session. For me, it's simple. It's communication. It starts with those of us on the panel to make sure that our services maintain those open lines of communication, because we got way more commonality then we have differences as we move forward, particularly in this environment. But most importantly, the communication between industry and the services. This is the only way we're going to get it right. We've got to have open lines of communication early on. Thing that keeps me up at night as I move forward, I'm laser focused towards our AOA this fall, is if we didn't reach out in the right arenas to make sure we had as much depth and breadth going into the AOA as we possibly could. So this is a session that makes me feel a little bit better that we're moving in the right direction. And I really appreciate the time tonight. Thank you.
And thank you again for being with us. And Lance, you get the final word tonight from our panel.
No, I just want to offer that, for everyone out there and all of our, teammates, both across the service and industry and here in this chapter, this is really an exciting time to be part of the modernization of aviation moving forward. We're looking at, things we talked about and put on paper and started building in the 70s, and they came to fruition in the 80s. Ideally, that same thing repeats itself 50 years later. Things we're putting on paper and beginning to fly in the 20s, we start producing here later this decade and into the 30s, and it becomes our new fleets. And they're going to be leap ahead. It's going to be transformational technology, and really, it goes just touched on it. None of this is possible without the the relationships and the partnerships that we have with our brothers and sisters in industry. They're able to kind of go together and arm in arm forward with some great products and technology. So that's all I've got to add for tonight.
Lance, thank you. Thank you again. And thank you to the panel again for, I know you guys put in tremendously long hours, hard work in the work you do, and to dedicate a couple hours in the evening on your limited free time to speak to our members speaks well of all of you. We appreciate your taking the time to do that. As I told you each in the run-ups to this session when we invited you, our membership ranges the bright young engineers that are about to jump out there in industry and really do the hard work of innovation, all the way through folks who've served careers in the military and now are on their second careers in industry, and we even have some of our more senior full retired members that keep their hand in what we're doing. And so you're looking at the sort of the life cycle of rotary wing or vertical flight aviation, and your comments are extraordinarily well received. So thank you again. That completes the panel. I have a few comments I want to make to our members about some chapter business. Our panel members are welcome to stay. It's just 3 short comments, and then we're going to go ahead and close things out a little, hopefully a little bit early. The first order of business is that I mentioned in our opening that we went virtual for this quarter's membership meeting, and our plan is to do that again a little bit later. So our second quarter meeting, which probably will be in the April timeframe, will be virtual as well, and we're going to be asking VFS International to host a similar webcast for us for our April meeting. But I think looking at what's going on across the U.S. in terms of COVID vaccination and developing some herd immunity, it looks like we'll be able to target the fall for a live meeting, bring our members back together. It's unfortunate we've not been able to do that, but we're not the only organization who's been facing that challenge. So I'm looking forward to getting back live, but you can expect a meeting in the April timeframe. We'll work the specific date with the chapter leadership here pretty soon. The second comment I want to make is that we talked about deferring our federal city chapter officer slate rotation, and we're earmarking that for the June timeframe. So it looks like as your chapter president, I'm a lame duck, and I'll work that process of nominating new leaders and rotating the officer slate in the June timeframe after that April meeting. And lastly, and our scholarship chairman Jim Cutting from Boeing is on board. Last year, and as you know, we've got a partnership with the University of Maryland School of Aerospace Engineering, and on an annual basis we hold and offer some graduate scholarship funds on a competitive basis. We are looking at doing the same thing again this year. Our goal will be to award before 1 May. So I'll be working with Jim here shortly to get out an announcement in the near term to show a timeline and talk about getting the scholarship applications in for the next academic year so we can get them awarded before the close of this academic year, ahead of summer deadlines on tuition and so forth. So Jim and I will have that discussion along with the chapter leadership at our next meeting, which will probably occur in the next few weeks, and students can look to see that announcement coming out hopefully before February is complete, showing the timeline for the application all the way through to award. Those are the three pieces of chapter business I wanted to cover. That sort of completes our agenda today. If anybody has any quick questions, I'll throw the Q&A back up, but other than that, I think we are complete for the night.
Okay.
And that's all I got. Thank you very much, everybody. Everybody have a good evening.
All right. Thank you all for engaging with the panel and the presentation. With that, I will go ahead and close the webinar.
Thanks, Chris.
All right. Thank you.